Hi, everybody. We'll go ahead and get started. Sunil, you can hear me okay?
Yes, Greg. Loud and clear.
Excellent. Okay, so my name is Greg Nolder. I'm the VP of Analytics for Denali Federal Credit Union. I'm also act as a community chair for CU-Lytics. A couple of quick notes, just updates for those of you who are part of the CU-Lytics community. A reminder that the CU-Lytics Analytics Summit will be in Redmond, Washington on March 13th and 14th. Also, an announcement that we are planning to add some hands-on workshops for the 15th. That's kind of a new announcement. It's not online yet, but you should be seeing some more information about that soon. Also, if you're planning to attend the summit, please consider entering the Analytics Challenge, which is a good way to sort of show off some of the analytics and share some of the things you've been doing. And then also a reminder that to check the CU-Lytics website frequently for upcoming events, announcements. There's also a very good solutions gallery up there with a number of vendor listings and reviews and ratings and so forth if you're looking for particular kinds of tools for your work. So I'll introduce today's speaker. Sunil Kappal works as a senior manager of analytics with R Systems. He has more than 19 years of experience in data analytics, business intelligence, statistical modeling, predictive models, and Six Sigma methodologies. Also, in his presentation, he may mention some more about his background. It sounds very interesting. The title of the webinar today is Risk Analysis Using Conversational Data. A description, risk lurks everywhere and in every business. This webinar will discuss how sentiment analysis, coupled with some advanced analytical approaches, is a technique that can help organizations identify and mitigate risk using conversational and sentiment data. Sunil will share a detailed case using healthcare claims fraud and then touch on a few other examples of how this kind of analysis might be used. Just a reminder, please keep your phones on mute so we can keep the background noise to a minimum. We are recording the webinar, so it'll be available for replay on the CU-Lytics website soon. And if you have questions during the webinar, please go ahead and submit them using the chat window. And if there should also be some time at the end if you'd like to ask a question live over the phone. So with that, I'll hand it over to Sunil and look forward to the presentation.
Great. Thank you, Greg. I really appreciate the introduction, and thanks to everyone for joining me on this webinar that is around how to identify risk using conversational data. So conversational data can be termed as speech analytics as well, conversational analytics as well, speech to text as well. So it is really great to be speaking about a topic which is very close to my heart because risk is something which is very, very common in each and every business, and it is sort of inevitable. And if we have got our ducks in a row, and if we know that what we really need to identify by using various methodologies and techniques, we can really identify those patterns by using various techniques and various data sets along with various variables within the data itself. And with that being said, I would really like to kickstart this presentation around risk analysis using conversational data. And just for the benefit of the audience, what I've done is I have divided my presentation into 4 sections. Currently, you all can see only 3. 4th is the appendix. And there's a theme to this presentation, that is awareness to enlightenment. And, in the awareness section, I'll talk a little about myself, and then we'll have a look at the economic crime landscape that, what exactly is the, economic crime percentage across the globe? What are those industries that are being, affected by this problem? And then we will also look at top 3 risk analysis techniques that can really help us to identify probable risks And then we will also look at an infographic that I did for a leading data science blog, where I tried to, visually show how exactly certain algorithms are being consumed within various industry based on the survey that was conducted by Kaggle. And then each and every team has certain key takeaways, and for the awareness section, the takeaways are the audience will be able to understand that why there's a great need of these risk aversion techniques, or so to say, risk identification techniques. And what is the percentage of these advanced risk prediction methods that are being used currently in the financial industry, to understand that where we are in 2017 and what we can expect in coming year, that is 2018, which is very interesting. And then in the educate section, we're going to try and understand what sentiment is in context to conversational analytics, followed by a pretty high-level understanding of what is conversational analytics and how it works, and how everything works in coherence to deliver a unified sentiment score and the capability to mine conversation. So it'll be all about how we would be using the conversational analytics data within our models, especially the case study that I'll be sharing with you all on this call today, and how that information is consumed to generate insights that were really important for the business. And then the third section is around healthcare risk analysis case studies, and we will also look at a couple of other techniques to identify credit risk, and we will also understand that what are those techniques that can help us to sell our products based on the customer sentiment. So in today's scenario, we have so many products available, be it any industry, be it financial institutions, be it telecommunications. There are so many products. What if we can create an offering based on the customer sentiment? So we're going to talk about it in more detail within this section, and we will also try to understand what are the potential benefits of these techniques. And the last section is appendix, where what I've done is I've included snapshots of the workflow that I created using certain open source statistical tools to perform various analytical routines. So with that in mind, let's move to our next slide. So a little bit about me. I'm a literature graduate, and I specialize in advanced data analytics, speech analytics, and text mining. And I have delivered, couple of lectures at the University of Texas, Dallas, around advanced analytics. And recently, I was also called as a guest speaker at the Symbiosis Institute of Operations Management at NASEC. And as Greg very nicely explained that what I love to do, I love to play around with the data. And considering the fact that I'm a literature graduate, at times numbers, they haunt me a little bit. But to overcome that problem, I started taking specialization certifications, and I've taken a couple of, specialization certifications from various universities. And in my free time, I love to meditate, and I love to conduct trainings on various statistical tools like R, especially the graphical user interfaces like Rattle, Deducer, R Commander, Orange Canvas, so on and so forth. So let's move ahead and try and understand and look at how exactly the economic crime landscape looks like. So on this particular slide, you would be able to see at a global level, the economic crime rate stands at 36%. And this data set is picked up from the PricewaterhouseCoopers survey, which was conducted in 2016. And you would be able to see that financial services industry is at the highest risk in terms of any economic crime. And then on the right-hand side, under types of economic crimes, you can see what sort of crimes are experienced, within almost all the industries. So we have the asset misappropriation, cybercrime. I think that you can read the top 5. It makes perfect sense that why we should be thinking of finding a way to predict whether a risk is about to happen or in what all scenarios, an economic crime can happen. Finally, when we, ask the question that, what do you think your organization may have lost through incidents of economic crime over the last 24 months, the numbers are simply mind-boggling. You can see that 1% of the respondents stated that, anything over and above 100 million. So it's a pretty big number. So this brings us to a very important point to think about that what is the current scenario in terms of what is the usage of such methodologies at the moment within the financial industry. And this brings us to a part where we can clearly see that at present, financial institutions are deploying 7%. It is pretty low, but only 7% of risk identification methods are being used currently. And, the industry expert says that the plan is to move this 7% to 11. And how this will happen, the next slide will actually, give us an understanding of, out of those 7%, what are those top 3 topics, or what are those top 3 techniques that are being used. The very first one, which is favorite of all, that is logistic regression. It helps to classify, any outcome into 2 possible outcomes, good or bad, and a lot of financial institutions are using logistic regression. If I may say, 68% of all the industry, they use logistic regression to classify probable outcome. And in case of financial institutions, they are using this technique to identify a good or a bad credit, followed by neural nets. Considering the fact that this is one of the complicated algorithms or techniques to deploy, so the usage is not that great. But again, a lot of financial institutions are using this particular technique to perform credit ratings prediction. And the last one is random forest, which is one of my favorites. And this particular methodology is also used to identify credit risk prediction. So talking about random decision forest, or also known as random forest, this is a pretty robust technique, or so to say, algorithm, because what it does is it creates multitudes of decision trees, and every node is sort of expanded. Once a particular node has a high impact variable, that particular variable is expanded into other nodes. And similarly, you can go up to hundreds and thousands of trees to get one unified probability percentage. And I'm pretty sure that these are something which are known to everyone, but there is one technique which has gained a lot of popularity, especially post the Enron financial statement fraud analysis, which was done by some college graduates. So Benish M model is a method that can be used to detect companies with a tendency of committing fraud on their financial statements. And empirical study says that company with high M score have a higher tendency of committing a fraud, which means that if the M score is greater than -2.2, then you can say that, yes, that company is probably manipulating their statements. And, it is not only about looking at the number and saying there are 8 variables with some financial ratios involved, through which this number is calculated. And those, just for, it's sort of good to know that those financial variables are sales index, gross margin index, asset quality, so on and so forth, basis which this particular score is calculated. And this has been very, very popular amongst the financial analysts. And it has also been said that it is better than Altman Z-score. which helps to predict the bankruptcy of a particular organization. So, that is the reason that this is one of the emerging techniques to identify financial statement fraud. With that, this is the last slide of the awareness section, where I'm just trying to show how exactly the risk prediction algorithms, or so to say, the algorithm landscape looks like or will look like in 2018. And I would really want everyone to focus on top 5 machine learning methods. So we are looking at deep learning, we are looking at neural nets, time series, Bayesian methods. And in our case study today, we're going to look at the Bayesian method that I use to identify or to perform the risk profiling of various healthcare service providers. And before I move on to the next slide, if I may ask if there are any questions that some of you might want to ask right now with regards to what all you have seen so far, or probably we can move ahead to the next slide as well.
I think most of the lines were set on mute, so let's move along and we'll try to collect the questions. If anybody does have questions, please type them in the chat window and we'll try to follow up either partway through or at the end.
Perfect. Thank you very much, Greg. And I think that it is a perfect point to start thinking of that how or what kind of variables, what kind of data sets we should be using to make these algorithms even more robust, even more result-oriented. And with that in mind, we will try to understand why there's a need to have sentiment as well as the voice of the customer-related data in our risk prediction methodology. So let's try and understand what exactly sentiment is. So sentiment is it is feelings. Sentiment is opinion, sentiment is likes and dislikes, and obviously sentiment is tone as well. So if I look at all these aspects, this is what I get. So if I'm feeling good, I will be using connotations like happy, sad. If I have an opinion about something, then I will be talking about, this movie was not worth watching, just an opinion. And likes and dislikes, I like someone, I don't like someone, I love someone, I love a brand. And similarly, tone, that is, I just can't get it. So if you look at the above 3, sentiment types, these type of sentiments or phrases can be mined easily by using text analytics or by even using, speech-to-text methodologies. But what about tone? So just think about it. The way I'm talking right now, I'm obviously excited. I'm obviously, anxious to understand how my audience is feeling about what I'm talking about right now. But that tone cannot get registered and cannot be mined by text. So that is why we need to have a way that we can include the, the tonal aspect of the way we communicate with each other, just to ensure when I'm feeling happy, I have a tone that makes me sound like I'm happy, so on and so forth. And similarly, as I was saying that there are ways that you can, mine the text related to sentiment, but that kind of analysis discounts the tone, pitch, the voice modulation part of the sentiment, and believe you me, this kind of information can really add value to the kind of analysis we can do for our customers. And with that in mind, the big question is, mining text alone to perform conversational analytics, is it the best choice? And my answer would be a yes or a no. It entirely depends. It depends the inclination of the organization, that what kind of analysis they might want to do. Do they really want to focus purely on the tweets that they are getting on Twitter and they just want to understand what their members are saying, compared to a financial institution contact center where they not only want to understand what their customers talking about their product, but also what do they feel about their product, and how that kind of information can help them to draw a distinction in between a highly satisfied customer compared to a highly dissatisfied customer, and what is happening in the middle. Do I have customers who are sitting at the neutral point, and is there a way that I can move them to highly satisfied or mildly satisfied, that kind of thing. So with that in mind, conversational analytics plays a major role in doing all these kind of machinations. So if we have to understand at a very high level that what conversational analytics is all about, it is about mining the interactions of the customers. It is about mining what your customers are saying, why they are calling your contact centers, why they are calling your businesses, and what kind of sentiments they are calling with when they are talking to your representatives. And it acts as a Google for audio. So just think about it. Your business might be receiving millions and millions and millions of calls. But within those calls, you have no way to identify that why your phone is ringing. So how you can do that? Even if your phone is ringing, whenever a phone is ringing, are you getting a happy customer or a sad customer or a customer who doesn't care? And in this kind of scenario, conversational analytics helps you as a quantification methodology that you received total 1 million calls, out of which 50% of your customers were happy, and remaining 25% of your customers, or rather 25% of your customers, they were sort of neutral, and 25% of your customers were dissatisfied. And now you would want to understand why they were dissatisfied. So whenever you want to get into the roots of what's causing what to improve your business efficacy, this particular application and methodology will greatly help. And obviously, it also delivers voice of the customer insight to the business. And at this point in time, majorly, this technology is used to perform fraud, risk identification, compliance-related calls, customer churn, and issue resolution. And obviously, when we look at this industry, we are looking at an industry which is expanding like anything. So we started with $100 million industry in 2015, and now what we are looking at a $1 billion industry in 2020, which is not that far off. So how exactly it works? So in the world of conversational analytics, every interaction is considered, as a conversation, be it speech, be it text, be it, Twitter, be it anything. And this is what is, what is kind of showing here, that what are those interaction sources. And once we have all the interaction sources, we pick the audio files, and we use the speech analytics or speech engine, which is powered by a language pack. If we have calls that are in English, U.S. English, we will use a U.S. Language pack, and if we are, we are somewhere in the U.K., we will use a U.K. language pack. Similarly, for almost all the geographies, we have specific language packs, and that is how we can mine the conversations. We can quantify that most of your customers are calling about payment-related issues or credit-related issues. And along with this information, what happens is your Twitter-related information, your survey scores, be it NPS, be it customer sat scores, all of this information is added as a metadata so that your analysts can search the results, and they can perform reporting and analytics on such diverse data set. So how does this help? This helps to to identify those issues that can really help any organization to to improve their profit margins, and that's how this technology delivers business value. And I'll take I'll take some time, especially on this slide, to talk about what exactly conversational analytics or speech analytics is all about. There are various technologies available today in the market, and the most common technology is word spotting, where you have a standard dictionary, you have certain words in the dictionary, and then you have a way of running all those words on your entire customer interaction, and that's how you gain the insight that most of my customers are calling about this issue, that issue, or some issue. However, it takes a lot of time, and the speed to insight is pretty slow. Whereas there's another technology that is phonetic indexing and search, along with the word spotting approach, which is quick because it works on the phoneme. Phoneme is the, it is the smallest unit of our speech. A standalone phoneme will not make any sense. However, once we combine all the phonemes, it ends up being a word, and once we have a way of identifying what is being said, so when a customer says, I'm not happy, or what the customer is not happy about, you can create context, and then you can come up with scenarios where the customer stated he or she is not happy about something. So I know that we do not have that much time to dig into the, dig into the details of how it works, but I really wanted to take this opportunity to give you all a high-level view around how this conversational analytics work. So with that in mind, the last bit is how I actually convert all this information into quantifiable information, into an information which makes sense. How should I be creating customer emotion profile? Because at the end of the day, I'm not only interested in understanding what are those topics which are driving calls, but I also want to understand what are the sentiments of my customers on those topics which are causing a lot of call volume within my contact center or within my business. And what you see right now on your screen is a very simple and straightforward process that any speech analytics or conversational analytics application follows. So how we decide or how we create the customer emotion profile. We create the emotion profile based on the tone, pitch, volume, and speed. And in case if we see a lot of crosstalk, that is people, agent and customer, they are sort of interrupting each other, that could be, that may signify a negative connotation. And followed by laughter. Laughter indicates positive sentiments and good feelings, but some of you might ask a question, what about a sarcastic customer? Customer is just, customer is kind of laughing, but at the same time is not happy. So that is the point where we bring in the additional data that I just talked about a while back, that every contact is an interaction. Every interaction, be it Twitter, be it, NPS score, everything counts. So what we do is we kind of do all that machination to come up with one unified score that if a customer is, customer's pitch is pretty high and there's a lot of crosstalk, but the customer is laughing and the NPS score on that particular call is of a detractor, then that particular call could be, mildly negative to highly negative. And similarly, if the NPS score is good, customer is happy, and then there are certain interactions which signifies like, I'm feeling really good about the services that have been offered to me. So this signifies a pretty positive customer experience, and that's how we, we kind of decide the sentiment scale. So this is the entire process, at a very high level as to how we do the customer emotion profiling. Now, the most important part. So we understand what is the economic crime, percentages across the globe, and we also understand that financial services stands at 48%. And then we know that, there are financial crime types that are happening. Top 5, we just looked at it, and only 7% of risk identification methods are being deployed by various financial institutions. So now what do we need to do? We need to look at all this information, and we need to understand that how exactly it has been used to perform a risk analytics, or how it is used to predict a probable risk. And this is one case study. So one of the largest US-based healthcare client wanted to profile their providers to understand, who are those providers that, who can potentially commit a fraud based on their demography, based on what we are able to mine through conversational analytics, based on the sentiment profiles and other metadata fields. And these were the these were the things which were given to us. Especially, we had the age-related metadata, we had the affiliation-related metadata, we were given the gender and what kind of provider they have within their system and out of their system, so on and so forth. And then we use two things to perform this analysis in conjunction with all the metadata that you see right now. We created the fraud indicator conversations, which I'll just share with you all that how we identified in the upcoming slide. And then we did the sentiment profile. And just a while back, we looked at that how we create sentiment profile. So once we have all this information, a lot of work, goes in the background to discretize, so to say, continuous data into, categorical data so that it can be used in a particular, algorithm or a particular mathematical equation. And in this scenario, I was using naive Bayes. So once all the data was prepared, what we did, we started defining, the first thing was we were to define the fraud indicators using conversational data. So what are those fraud indicator, scenarios? So it is nothing but a structured rule set where we create or where we query the system to give us calls where certain things are being mentioned. And to be more specific, we created certain risk indicators or scenarios. For instance, providers billing for services not provider. And what was the speech analytics data? It was voice of the customer, where the customer is complaining that a service is not rendered, yet he or she has received the bill from the from the provider. And the kind of analytical insight it provided was there were multiple services rendered, and out of those multiple services, customer just opted for one service. So what about the other services which were mentioned on the invoice or on the bill? Similarly, we wanted to understand if there are specific mentions of benefits assignment, and the voice of the member, you can see that voice of the member or agent stating that benefits were assigned. And then once we have all this information, as I said, we start creating those risk profiles. And when we did that, we were able to see some interesting things. So when we looked at a male service provider with an age group of 30 to 35, where a lot of conversations were happening related to medically unrelated procedures, and the sentiment was neutral, the probability of this particular provider committing a fraud was just 39%. But the moment we change the in-network, piece of the puzzle to out-of-network, you'll be amazed to see that it grew from 39% to 61%, which means that a jump of 22%, merely by changing the affiliation of the of the provider from in-network to out-of-network. And in a way, it makes sense as well. People or providers, those who are affiliated to a particular health plan, they'll be very cautious when it comes to offering services to the members, and they will ensure that they are not rendering any service which is not required by the member. Whereas an out-of-network service provider, might think otherwise. And then we were also able to identify a loophole within the entire system. The loophole was that the in-network and out-of-network information for each and every healthcare plan is updated either on monthly basis or fortnightly basis. So if somebody wants to commit a fraud, they can easily do that within those 15 days or within those 15 to 30 days, so to say. So that was pretty interesting, and client really liked the information. So that's what I was talking about a while back. But even more interesting, the moment I bring in out-of-network provider with high negative sentiment, where people are talking about medically unrelated procedures, so the probability increases from 61% to 62%. And then what we did, we really wanted to uncover lots and lots of scenarios so that we can pick one scenario and then we can the client can do further scrutiny on that scenario. And this is what we were able to identify by purely using the conversational sentiment data along with the metadata delivered to us. We were able to identify whenever there's a medically unrelated procedure with high negative sentiment, it'll be 61% probability. Fraud probability would be 61%, and the benefit assignment with high negative sentiments would be 73%. And similarly, providers, those who are out of network, have a higher tendency of committing a fraud. So the client decided that they're going to work on the benefit assignments where the negative sentiment is high, and then further what they decided to deploy advanced mathematical techniques, if I may just talk about it a little bit. So what I know from my experience, and I also wrote a research paper around this, that a lot of healthcare service providers, once they have these kind of profiles, they deploy, Benford's law. So Benford law is also called as the first-digit law, and this is a probability model that is a very powerful tool for detecting fraud and data irregularity. And I will not get into the details of what exactly Benford law is, but it helps us to understand if your claim amounts are not falling within the Benford's law curve, there could be a high probability that those claims are not right. And you can further establish the statistical significance by deploying, chi-square statistics on it. So this was something, which was really helpful for the client, and they really enjoyed this particular analysis by utilizing the conversational analytics. So this is about the healthcare, risk prediction method that was used by one of the leading healthcare. And then there are other use cases as well. For instance, credit risk, decision tree learning, and that's what I was talking about a while back. Personally, I love this way or this particular algorithm because it really helps me to pinpoint a very specific scenario where I can, I can clearly show whether this scenario would be a fraud instance or not. So if you look at this fraud, where fraud probability is high, there have been fraud alerts 3 times or greater than 3 times. If it is not greater than 3 times, the probability is low. But just think about it. You can top it up with sentiment profiles with various interaction types that you think can be the indicators of a potential fraud. So this is one of the use case, and then the other technique that is being often used by a lot of financial and telecom institutions is neural net. Considering the fact that it is not that popular within the analytics community, and in the sense it is very complex to create a neural net learning. However, the good news is that there are so many open source, applications available in today's scenario that without you having to, write pages of code, you can just simply use the graphical user interface to create these neural nets and deploy these neural nets on your real-time data to understand whether a particular scenario will end up in a fraud instance, or a non-fraud incident, if you will. And I'm someone who's very inquisitive, and a couple of days ago I was just going through various webinars, and while going through webinars, I also happened to stumble upon a particular webinar where everyone was talking about that how we can ensure that we pick the right right advertisement channel to promote our product. And this is something which is very, very simple yet very complex. And I don't know how many of us have read about ZMOT. So ZMOT is a zero moment of truth, which was introduced by Google in 2011. So Zmod is something that helps the service providers to create that buzz for their product, in between the phases. That is stimulus, when a customer thinks about, buying a particular product or a service from a service provider, and in between the first moment of truth. So let me take some time to explain what exactly I'm talking about. So what I'm talking about is the customer wants to open, a savings account with a bank, okay? And till the time the customer is not getting into the bank physically, the customer will try to go online and will try to understand that what are being said about this particular bank, what kind of services this bank is offering. That particular scenario is called as zero moment of truth, because nothing has happened right now. So the first moment of truth is the moment the customer steps into the bank, and the moment customer starts to interact with the associates in the bank. And and then the second moment of truth is once the customer is bank's member, and now they know what kind of services are being offered to them, and now they have some real experience. But till the time the customer is in between the phase of stimulus and the first moment of truth, we can do a lot of analysis to ensure that we get all the customers in our branch. And how we can do that? We can use our historic data, and we can see that whenever we enrolled a particular customer, what sort of advertisement channels helped us the most. And then you can layer up your sentiment data on this, and then what you can do is you can perform a simple correspondence analysis or a multiple correspondence analysis, and you can see that on the extreme right-hand side, where you can see that print media and emails, and social media always ends up in a highly positive experience. And probably these could be 3 or 2 advertisement channels where you might want to focus so that you can get more and more customers. So these are some techniques that I kind of shared at the University of Texas Dallas as well, and we had a lot of workshops around how we can deploy all this knowledge to get some sort of insight that is really beneficial for the business. So what are the potential benefits? So the potential benefits are improved customer loyalty. Once you know that you have a way to safeguard the information of the customer, once you know that you can identify the fraudsters, you can save the customer data. So obviously, it will help you to improve the customer loyalty and customer experience. You will reduce the cost reduction. Obviously, when there are data breaches, when there are, customer information-related, issues, then there are certain monetary and regulatory complications that an organization might get into, and that can cause a lot of, bad reputation for that particular organization, along with some monetary penalties as well. And then this also gives you a way to do a proactive risk mitigation that makes you a thought leader, in the sense that I have a way that I can ensure that my business is safe, in the sense I would be able to identify those risk scenarios, and I will definitely have a mitigation plan to ensure that there is minimum or no risk at all. So with that, I just want to take some time to show you that, how I created the naive-based classification. So this is one of the open source softwares where you can create a workflow. So if you will see, I use the file. So this file is the file fetch widget. And you can use this widget to bring in Excel or CSV or any sort of file. Or in case if you have database, you can link your database as well. And then you can select a sample. You have the option to do sampling as well. And then what you do is you connect the model widget. In this scenario, I use naive Bayes, and then I connect this model widget with the test score widget. And then I also connect the data sample. And that's how it helps me to predict and that's how it helped me to understand, what is the accuracy of my prediction. And if you look over here, you would be able to see that, area under the curve is 78%, and classification accuracy is 82%. F1 score is this. So it's a pretty nice way to to create models that can be deployed directly onto any data type, along with the confirmation that you are doing something with high accuracy, and that is something which can be written as a code as well. Because the cool thing about this particular tool is that you can write your own Python code, and you can kind of throw that code within this particular application to create your own customized risk prediction algorithms. So with that in mind, this is one of the simple correspondence analysis that I was talking about. So I will not take much time here, but what I'll say is that in today's scenario, there are so many ways to do risk analysis, especially using multitude of data. The only thing, what I believe one has to have is the drive to find various ways which are effective, not only in terms of effort, but also in terms of cost, and are result-oriented and should be done in collaboration with the client. And that's how you would be able to perform these great feats as far as the risk prediction analytics are concerned. So with that, and with that note, I would just want to thank each one of you. And if we have any questions, Greg, probably we can unmute the lines.
Sounds good. I'm going to a couple of things. First, I'll unmute the lines. But while you're taking a catching your breath there.
Thank you.
Thank you. While you're catching your breath there, I will say I did get one question through chat from Paramal, who's asking about the 8 different variables in the Benish-M score. And actually, I'll give you a rest. I was also interested about the same thing and looked it up on Google real fast. And I'll just say that the variables are all financial ratios, and they're probably more than we'd want to discuss here in detail. But there's a lot of information online. And so it sounds like an interesting tool, and I was curious about it as well. So while we're waiting for other folks, I have a question. I have probably more than we have time for, but I'm curious about if you could talk a little bit about that. I was going to ask about the tools you use and whether they're open source. Can you sort of be a little more specific on the kinds of tools you like to use? And then also, I know you're part of an organization that provides outsourced consulting, but are these the kinds of tools that perhaps some of the folks might be able to use on their own for at least basic analysis?
Definitely, and my answer would be yes. So the tools that I've used to perform, all these analytics or techniques, the first one is Orange Canvas, and this is an open source tool, and it's a graphical user interface, a workflow interface where you can create a workflow to do data visualization, to create predictive models. It is comparable to RapidMiner. So I think that this is one tool that anyone would really want to have in their hip pocket to ensure that they are doing all these analytical routines, pretty quickly. And then the other one is R. So just think about it. I'm a literature graduate. I'm an honest English literature graduate, and I can hardly code. I can code, but I don't code that much. So what options do I have? So within R, I have the option that is called as Rattle. Rattle is one of the GUIs that anyone can use, and it follows the CRISP DM methodology, that is cross-industry process for data mining. It follows that format to perform analysis by just selecting and choosing options, and you can create models like random forest, You can create, logistic regression models, and you can deploy those models real time. And you need not to write even a single line of code. And the best part is that if you have coders on your team, that particular, application generates a code in the background. Your coders can pick that code, and they can further tweak the results to make your models even more, robust. So I think that along with Orange Canvas, I would highly suggest R, RETL, R Commander, Deducer. These are a couple of open source tools that, you all might want to think about.
That's great. I do analytics myself, but as a parent of a humanities graduate student, I like that maybe there's lots of opportunities out there for people to do this kind of cutting edge stuff, which is important in the world, but also you don't need you need more the high level. It's almost more important asking the questions now, it seems like, than the tools you're using. So which is really great. I'm curious. Well, here, I'll open it up. Anybody on the line have a question? If not, I have a couple more myself. Okay. Well, if no one wants to jump in, I'm interested in the voice analytics in particular because I've often wondered when I get on, or I wonder if you've seen, when you get on the phone with a company, when you're calling customer service, one of the most frustrating things is when you're in a voice response sort of a situation, and where they say, hey, say customer service or say technical support or whatever, and it gets very frustrating. I wonder, have you read about people using that in almost real time to do the analytics on the tone? So someone's getting frustrated, you want to move them up the line in terms of they're getting really tired of answering automated questions rather than talking to a real person.
Yeah, I've personally, I have not worked on this kind of data, but yes, I've heard, a couple of my friends working on this technology, because at the end of the day, whenever a customer calls up at a particular contact center, so in your case, press 1 for technical, and you'll say, okay, I'm pressing 1. And this is how, the customer's tone deteriorate, and we have technology that captures that. And then we have, we have the functionality of identifying those customers and giving them call steering functionality, if you will. So the customers who tend to get, frustrated pretty easily, then there would be a voice prompt which says that, hey, you're being on hold, or you're waiting for the next representative from past 2 or 3 minutes. You can, punch in your number and we'll give you a call. So I've seen those kind of things happening. So in a nutshell, yes, it is very much possible.
It's very cool. So I'm curious in kind of when you do these projects for clients, whether it's the insurance company, for instance, is our systems kind of building the system and handing it off, or are you guys involved in a long-term engagement with them where you continue to do analytics periodically and update it, or how does that generally work with this sort of engagement that you worked on?
I won't be able to expand that much on this, but yes, we are in continuous engagements as well, and we do take one-off projects as well. Because just think about it, we have a solution, and we would really want our clients to use our solutions not only for months but for years. So obviously the other prime factor to make the application sticky with the client is to offer services where we can actually tell the clients that how to use this technology, and then sort of do some level of hand-holding, if you will, Greg. And that really helps us to, one, create a rapport, and second, to work, in collaboration with the client by offering, analytic services as a team on a long-term or on a one-off project as well. I don't know whether this answers your question or not, but, this is what we do. We are in both. That is long-term engagements where we continuously do, projects after projects, and we also do one-off projects.
No, that's it. I think the reason I bring it up is I think it's important I think you'll find, I think in every industry there's a broad range of capabilities, and there's probably a lot of opportunity for folks who want to get stuff done to kind of essentially partner long-term with outside analytics organizations to really, leverage this.
Sure. Yeah.
Well, good. I think we're kind of at the end of the hour. I'll see if anybody else would like to ask a question or that's on the line. Doesn't sound like it. Well, great presentation, Sunil. And by the way, I hope I'm saying your name correctly. I apologize if I've been mispronouncing.
Not at all.
However,
not at all. You are.
Really great presentation. I'm glad to have sat in on it, and I'll even be suggesting my daughter, who's actually a linguistics major, listen to it later to hear some of this stuff. So,
wow.
Really,
thank you.
Yeah, thank you very much. Yep. And also thanks to all the folks who've joined today from Thealytics. Please hit the site periodically and stay tuned for the next webinar, which should be on the calendar soon.
Thank you all.
Okay.